Hello and welcome. Today we're recording another episode on how to make our cities healthier, more prosperous, and build a better future for all our children and the next generations. Today I have with me Nolan, who's a registered architect in the state of Alabama. He has a master's degree in architecture from Georgia Institute of Technology, and he has been practicing architecture for over 17 years. Most importantly, Wade has pioneered and mastered the prefabrication of light gauge metal framing. So today he's going to talk to us about how to prefabricate buildings and make them more affordable, accessible, or maybe mass produce. All these interesting questions you might have wondered. Hello and welcome, Wade. Thank you for coming to our little show. Would you tell us a bit more about yourself?
Yeah, thanks for having me. Yeah, I guess, you covered it pretty well. I'm here in Birmingham, Alabama, and I've worked for a bunch of different architecture firms and also a modular manufacturer here in Alabama. And now I work for a modular kind of integrator called Rad Technology, and we do modular radiation oncology clinics. So yeah, I guess about 1, 2, 3, 4, 5, maybe 6 years ago or so, I kind of left typical architecture practice and started going into this prefabricated modular stuff, and it's kind of stuck.
Awesome. So yeah. Tell us about the prefabrication of light gauge metal. What is rad? All these cool stuff. Do you think it's going to be the future of architecture? Is it going to be exclusive for healthcare and really fast-paced projects? All these questions, million questions.
Yeah. So with no, I mean, the light gauge stuff isn't exclusive to healthcare by any means. There's, in healthcare, because of codes and whatnot, it's metal framing, and the digital fabrication side in healthcare, can be more important just because of the complexity of the buildings. And the cost of rework is very high. So going into these projects with a higher level of development than you would see in typical projects, really is just all about getting things as coordinated as possible before problems and RFIs start occurring on the job site and work stops or work has to be redone. So yeah, just investing a lot more time on the upfront through BIM modeling and getting all the trades involved very early on, so that coordination process goes as smooth as possible. And yeah, it's just reducing errors out in the field is really the main objective.
So some of our viewers might not know what's the difference between metal framing and prefabricated metal framing. Would you tell us a bit more about this process?
Yeah, sure. So typically metal framing in the past, when you're framing a light gauge steel wall, a metal framing contractor would just buy um, track and stud sections in, typical lengths, whatever they're receiving from their supplier. And then, the guys out in the field would have a chop saw and, measuring tapes, and they just kind of go at it, and it's loud, and there's guys that are very fast, and sometimes that process is faster than if you don't have a lot of things to coordinate against. That some metal framing contractors are very fast, faster than wood framing. But for there's a handful of these companies down in New Zealand, actually, that have created this technology called automated roll forming, where you're able to design a wall in CAD or BIM software and produce some code that you load into the automated roll forming machine, and that machine cuts everything to length and puts punches into the stud where you can have service holes or bolt holes or deflection slots, or however you configure the machine. This is just showing Howick, which is one of the manufacturer of these type of machines. There's a handful of manufacturers out there, it can make framing one of these light gauge steels walls very fast and extremely accurate. These machines are accurate to within the hundredth of an inch. So it's really all about precision, and an architect that's familiar with this type of tech can have a lot more control over how the building is framed and built. That's really what a lot of this digital fabrication stuff is about, is giving control back to architects and designers, because architects have just given away so much control due to liability reasons over the past couple hundred years, where the idea of the master builder in architecture is really gone. But through digital fabrication and control of data, I think it's a opportunity for architects to take back some of that control over how buildings are built.
Yeah, true, absolutely. So that is a great point, which leads us to a question of how does the project delivery method work in these kind of projects, or at least the projects you have been working on. So how do you coordinate with the owner? Is it design and build? How do you find contractors responding to this new method of design and construction?
Right. Yeah. So the first, when I first got involved with this light gauge stuff, I was working for a modular manufacturer where it was a very, vertically integrated operation, where the modular company was started by architects, we had all types of machinery in house, where we were, we had a steel beam line for drilling holes in HSS tube for building our own, large scale volumetric modules. And, we were just taking more and more scope in-house gradually. And, we had our eyes on one of these automated roll forming machines for a while. And then, finally, when the time was right and we had the volume of work that supported it, we jumped in. But I've also worked on projects where just a light gauge framing contractor that decided to start a business, by purchasing a couple of these machines, and they work on projects that are typical, design, bid, build stuff, where, they just bid interior framing projects, on the same way that, a typical light gauge contractor would, but, they have the advantage of, the machinery and, they might have to go through the same shop drawing process, but, when this contractor that has two Howick machines is creating shop drawings, they're also, creating code for their machinery at the same time. And then, they can frame the panels in-house or bundle them and send them to the site. And, everything can be coordinated already for HVAC systems or plumbing or whatever. So, I've worked on kind of all project delivery methods, I would say. Yeah.
So some contractors seem to like it. How did owners respond? Did they find it efficient? Did they? How do you get the idea across to, let's say, developers or owners?
Yeah. So for an owner, it's with, I guess, light gauge steel and this, taking this extra effort and coordination and BIM modeling on the front end of the project, really it's all about, precision and accuracy and being able to deliver a better product to, building owners. So, I mean, that's going to be the main selling point when trying to sell it to a developer or a hospital client, would be that, we model all this stuff on the front end. You don't see many hospital projects getting built where someone's gone to the effort of modeling every single stud in the entire building. But with a lot of automated stuff and Revit or some other CAD software, you're able to generate the metal framing. I'm not drawing every single stud, but I'm using a bunch of add-ins to Revit and custom dynamo stuff and that type of thing to generate all the framing that then we're able to coordinate against with all the other MEP trades. So
that's engineering. That's probably the dream of the architect's work, like building.
I mean, I've worked in coordination, BIM coordination on projects where a lot of this stuff is happening in healthcare, just because the cost of healthcare construction is so high, that compared to other building types, really the money just isn't there to put the effort into paying a bunch of BIM modelers to do this stuff. I've also worked on residential stuff though, where it's just the contractor has decided that that's doing a lot of BIM modeling and modeling the projects at that higher level of development is just going to be the way that they work. And that they don't want to have rework out in the field, and they want to, devote themselves to being able to deliver that, level of work instruction to their employees, and just so that everybody knows what to do next. The bar is in construction is just ridiculously low.
Awesome. Go ahead.
And yeah, I've worked, on projects where, work, hit the field, and it was just a matter of nobody knew what to do next. And taking the extra effort to, put a lot into a BIM model. I think a lot of people underestimate the value of it. But when you're able to reduce a little hospital into components that look like this, where we've modeled everything down to 3/4 inch conduit in every junction box, and all supports and hangers and everything. And then guys in the field are able to open an iPad or their phone and look at this stuff and understand what they need to do. And then with the metal
so they
framing,
use the active file. Cool.
no, they wouldn't use the active Revit model. But we have different ways of hosting it, or whatever, whether it's through BIM 360 or something else. But yeah, nobody's opening up a Revit model and poking around.
Okay.
But
yeah, but it's cool to see it in 3D. And yeah.
Right. Yeah. Yeah. A lot of guys just aren't out in the field, aren't, professionals at reading 2D documents, especially these days. So, but everybody knows how to open their phone, and, especially younger guys know how to spin around things and navigate through 3D space from playing video games and whatever. So, I've seen a lot of guys on factory floors and, out on the job site that are much more adept at spinning around a 3D model than they are at flipping through a set of 2D drawings, trying to hunt down a problem.
Definitely true. Wade, why don't you tell us a bit more about the residential projects, and how did the developer had that experience? What was it successful, or did they enjoy it? Did they continue doing it?
Right, on the residential side, yeah, it's been just in the past, I think it's been less than a year that I've kind of been involved on a few residential projects. But yeah, this contractor has a building method where they want to do a bunch of prefabrication, and they're using quite a bit of different building technologies with SIP panels and some kind of heavy timber stuff. And then also, infilling interior walls with light gauge steel. And, they're doing quite a few floor plans, multiple times, but then they were also have just kind of developed this building system where, things are changeable design wise, but, everything relies on this same building system, so that if an owner or developer wants a different floor plan or changes in the floor plan, they're able to adapt to that and keep the same building system. Which
That's brilliant.
if you getting into prefabrication, and if you want to automate a lot of processes, you've got to kind of choose certain building materials and components. You can't build a machine that's going to, build anything out of any material. But if you, choose some certain, building systems and materials, you can, really master those and start developing processes and automating things and, start really trying to go lean with, how you approach things. But it requires, sticking to your rules and, having, some discipline about, not allowing your client to just change whatever they want, but, stay within those constraints so that as you're feeding things into your, your machine, your building process, it's always going to be something that is able to be fabricated and constructed. So if you're working within your parameters that you've set up for yourself, you can have the assembly line from design all the way through fabrication and assembly and, building completion.
So just as any industrial idea and fabrication, it's the more you produce, the more affordable it becomes. And that's the idea. You cannot design or have a machine to produce highly customized product if we're talking about buildings as a product. But people can customize with, let's say, their finishes, the colors, just like I had this idea, and I think when we talked before, you shared with me that one of your former founders of the idea was inspired by the idea of manufacturing cars, and I think that is an excellent way to advance the construction and building construction methods in the future. Well, and it doesn't have to affect the custom home building. If you're a billionaire and you still want your lake house to be one of a kind, you still can have it. But to use a new method that can produce housing, especially we still have a housing with the prices, and we still have a housing problem. So do you think that this would help if it was used for housing? This construction method would make housing more accessible to the people.
Yeah, these automated roll forming machines have been used for, when they were originally developed, the intent was that they were for like disaster recovery housing. After it was like a hurricane hit New Zealand, and somebody showed up with, one of these machines that they had invented, and wanted to use it for rapidly building homes. So it's definitely viable. But there's guys out there that can frame wood houses really fast too. But really it's all about having a team put together and taking lean methodologies into construction. If you're able to plan and execute things fast with wood framing, then absolutely, there are some advantages through the BIM technology and with automation, these machines are basically a 3D printer for putting a structure up. They don't look like what a people typically think of, for a 3D printer, most people think of this kind of thing. But, these light gauge machines, let's see, the framing comes out of the machine, and these guys are able to build these panels on the shop floor,
Yeah.
very rapidly.
It reminds you more of a laser cutter more than a 3D printer.
Right. Yeah. It's kind of like a laser printer or something like that. Yeah.
You've mentioned like urgent homes in areas of disasters and healthcare. Is there and housing, and the basic idea is there's precision, there is speed, and mass production. We probably everyone can agree that it's not going to be feasible to use a method or put all this effort of designing all these little pieces and for one project only. Or is there a certain type of project that you think would use this construction method to the max?
A certain building type?
Yes.
Yeah, it's in health, I have a history in healthcare using this stuff, obviously, and it's really the complexities of healthcare construction are when you're just coordinating a ton of ductwork in a hospital ceiling and all different sorts of plumbing for med gas and other things in a hospital, being able to design all the metal framing ahead of time and plan for those openings that are required and all of those different devices that are hosted in the walls, and plan for all the blocking required for all types of casework and cabinetry and things. It's just really about making all that process go faster out in the field, and making sure that there aren't any errors and omissions in the work. But so yeah, any more complex projects, I think this tech definitely lends itself to. But there's also guys out there right now building just very standard looking hose with these metal framing machines, just because they're able to do it very rapidly and with a lot more precision and control.
Okay, so my next question would be, if I was a developer and I'm building, let's say, houses, how many typical or prototypes of floor plans would make this process feasible for me?
One of the beauties of digital fabrication is that, like a CNC machine, for instance, it doesn't care, it can cut the same thing over and over just as fast as it can cut something different each time, as long as you keep feeding it, new code.
What I mean is to cover the design expenses, because we're going to spend money on the designing the prefabrication or the coordination drawings.
Right. Yeah. Yeah. Obviously, the more times you build something, that you've invested a lot of money in coordinating on the front end, yeah, you're going to see more profit on that, that project the more times you do it. But yeah, as far as giving you an exact number of houses that you would need to build after you,
Yeah,
build
roughly.
a LOD 500, Revit model of it, I don't know, who knows? It's really about controlling risk also.
Sure.
What's the value of, eliminating any coordination errors out on the job site,
Yeah, when you have 200, let's say 200 units and 200 mistakes, it's completely different than one mistake. So you need to be very precise.
Right. So yeah, I couldn't tell you how many housing prototypes you would need to build to capitalize on the initial investment of, hiring some Revit modelers, but
it's gonna pay off. Definitely
yeah,
it's gonna pay off. I heard a lot of people talking about metal framing being not sustainable, or but let me reframe that, not being it's difficult to be energy efficient when you're using metal framing. What would you counter? How would you counter that?
Typically on the healthcare projects that I work on, the metal framing is required as for its fire resistance. But and usually on those buildings we're using an EFIS, an exterior insulating finish system on those buildings, which is basically just foam, wrapping the entire exterior of the building. And you can do similar things in residential construction, where Zip makes a insulated panel, where basically you're putting a foam thermal break between the stud and the exterior of the building. And you can also do that with just, I've also seen gypsum, exterior gypsum products, and then just foam put on top of that. So, there's various ways of insulating the structure to kind of create that thermal break. But as far as, steel versus wood, as far as sustainability, yeah, there is more kind of energy embodied in that steel, but, there's something like at least 90% recycled content in any steel that you're going to go buy today. I think steel is the most recycled material on Earth. So, there's pros and cons to both sides there.
Where does the steel that you've used on your projects come from? Is it imported? Is it made in the US?
Yeah, I think it's typically made in the US. And like I say, the majority of it is recycled content. That here in Alabama we have Nucor is the big steel supplier, and when you're buying steel for one of these machines, you work through distributors that buy from the steel mill, and those guys buy the steel in huge coils, and they slit it down to the widths that you need for your machinery. And then getting into that steel purchasing process is all very competitive, and yeah, it's that when you used to buy steel you get pricing that may last for a month or 6 months or something, but now usually it's like 24 hours that your quote on a steel coil might last.
Oh,
Yeah, just because the market is in such, fluctuation right now because of
mm,
the tariffs on Chinese steel and um, all of that good stuff.
mm. So thank you for answering all these questions. Wait, if we come to our closing question, and let's pretend that I'm a developer or city who wants to develop affordable housing. What advice and exploring ways to build things faster and more efficient? What advice would you give me?
Yeah, I would say, light gauge steel's an option to explore. Um, One of the big things with the automated roll forming is, there's just a lack of trained people out there in the workforce right now. And so, um, anybody can learn how to put together one of these, framing panels out of an automated roll former. They can be taught how to operate the machine and read the drawings and assemble a panel. Anybody can be taught how to do that within a couple of hours. um, but teaching someone how to frame a wood house, that takes years of experience and knowledge. So I think that's one of the things um, that some of this digital fabrication and technology can offer. But yeah, it's also just about putting it together a team of people that
Know
know
what they're doing.
know what they're doing, and that's really true in any uh, building system or building methodology. Is um, if you're trying to build or put together a program to build uh, low income housing, low cost housing, it can really be done in many different ways, and it doesn't have to require a lot of technology or um, you know BIM modeling or anything. It's just that effort that goes into planning the project and approaching things with kind of lean processes, and that eye for continuous improvement and um, you know uh, yeah. But yeah, this light gauge roll forming is definitely one method that can support those processes.
Well, in my area, affordable housing is becoming mixed with market price housing. So you'd see a building that is pretty neat and has 50% affordable housing, 50% market price, and it's still uh, very pretty good building, pretty nice. Well,
Right, yeah, that's happening here in Alabama and Birmingham. Also, there's actually a housing project just down the street from me is being torn down this week. Yeah, they're going back with mixed income housing when it's being rebuilt. Um,
yeah, which is great. Well, wait, thank you very much for um, l- giving us so much information and sharing your knowledge about this new technology. And to our viewers, if you have any comments and questions, leave it in the chat or reach to me to my email. Or I'm going to also share Wade's website address and email address probably, so you can reach out to him if you have any comments or questions. Thank you very much for listening or viewing, and see you in another episode. And again, thank you, Wade.
Yeah.